So before understanding how rate of change is used in real life, we need to understand what rate of change is and how it is used in calculus. So one of the fundamental ideas of calculus is finding the tangent line to a given curve. For the curve of a function, the tangent line is generally regarded as a line that passes through a certain point or certain points to touch the curve at that certain point. Well, what does that touch really represent? That touch at the certain point represents instantaneous rate of change at that specific point on the graph. Whether that instantaneous rate of change be in the speed of a car, or the size of someone's height, or the economy, the GDP of a country, for example. And with that, recall that finding the derivative of a function is finding the instantaneous rate of change. And that derivative of the function is also equal to the slope of the tangent. With that in mind, if we were to find the tangent equation for that tangent slope, what we're essentially finding is the rate of change of the function with respect to its independent variable x that is instantly changing at any given point. Well, how do we do that though? Well, this problem was solved in 1629 by French mathematician Pierre Fermat, who, using his methods to defining tangents, developed a way to find equations of curves of lines and tangents of tangent lines of equations. So how did he find it? Well, first what he did was take 2 points of a graph or a function and find the average slope, or as in math terms we call it the slope of the secant line. After finding the slope of the secant line, he found the limiting value of that certain slope, and as we have learned that usually the limit is approaching 0. So after finding the limit and applying the limit, whatever was left over, the value that was left over, would be considered the slope of the tangent. And with this method, he managed to find a equation and a function for the tangent line, which would allow us to find instantaneous rate of change for that said function.
So before I get more into this topic, I'll tell you guys what rate of change is. So rate of change is generally expressed as a ratio between one change in one variable to corresponding to another variable. So derivatives is one of the most important chapters in calculus, as you guys already know, and rate of change is one of the most important applications of derivative. This is the fact that f prime of x represents the change in f of x. There are many questions in calculus that we do in which we have to find a derivative of a function or whatever question we have, so we have to use rate of change for it. Like there are questions like determine all the points where the following function is not changing, and they will give us a function, then we gotta find its prime using rate of change and stuff. But like rate of change is not only used in calculus, even with calculus we can use it with more stuff as outside calculus, like how like a GDP of a country works, how population of a country grows and go down, how the currency of some country is going up against other or it's coming down against other. So there are many other ways other than calculus where rate of change is also applied to.